Here is the H8-5 console, serial I/O, and cassette tape interface card. And oh, it is something, isn't it? It has a pair of 8251 UARTs on it. All of the configuration is done with soldered in jumpers, as Heathkit liked to do. That bothers me. As we mess with this and try to get it going, I'm going to take these jumpers out. I'm going to solder pin headers into all of these jumper holes, and then we can wire wrap between them, and it'll be much easier to change the configuration of the card later that way, I think. This section over here, I assume, is all the cassette tape interface stuff. I haven't read the manual yet. I probably should have done that before filming a video about the stupid thing, but well, that's just how we operate here in the old computer shack. Dumber than shit. But there's a pod here for space detector adjustment, so I assume this kind of acts like a RIDI interface. And it's jumpered to 1200 baud, the standard speed, which interestingly is slower than the terminal speed. It's the terminal is set to 600 baud, which I think was the default speed of the H9 terminal. However, I'll be hooking this up to an H19 terminal, which will run at 9600 baud, so we ought to be able to re-jumper that with some wire wraps there. And I want to try, well, I'll get into that, what I want to try to do with the tape interface here in a second. It's got all kind of funny stuff on it here. You can switch this header between TTY and EIA, which I assume means a 20 milliamp current loop, or RS-232 type signaling, although they didn't call it that yet. EIA in the old computer books generally means very much like RS-232 usually. There's a bunch of stuff here. This looks like it must be for the gain of the output, whether it goes into a line level or a microphone level input. I don't know. So cassette tapes. I don't have a tape player anymore. I've got a bunch of tapes in a box somewhere, but I don't know where they are. But I don't have a tape player anyway, but this is just a serial interface that I assume does some kind of frequency shift keying, very much like RIDI. So I think we can probably pull whichever UART it is that runs the cassette interface and bend some pins up and hook it to a serial line level converter and run it like RS-232 over a null modem cable to a Linux box, and then we can cat stuff back and forth to the serial port like tape images, right? And it might be interesting to eventually try to make like maybe some kind of ESP8266 thing that could plug into that, and then you could like load and save tapes. Oh, pardon me, it's getting late. Over Wi-Fi or something like that. Although if/when we get the disk controller working, that won't be quite as important. But it would be interesting to that would be interesting to be able to like dump disk images through the cassette interface and write them to actual physical floppy disks via a Wi-Fi interface, like I was just talking about. That would be kind of cool. But anyway, for the moment, I think we just want to do the simplest thing that we can do to get tape images loaded onto the machine. We can probably bend those pins up and put a Max 3232 on a piece of proto board somewhere with a pin header on it, and then we can make a cable that goes from pin headers to like a DB9 connector that we can mount in the back of the machine there. And then we can just plug a null modem cable into it and rock like usual. And it's got a switch here to swap the terminal port and the cassette tape interface, which I assume was meant to be used with like ASR33 teletypes that had paper tape punches built into them. But Once we do that, I think we can probably jumper the cassette interface to 9600 baud as well. Maybe, depending on whether the monitor can run that fast, I guess. We'll have to experiment a little and see what works, but that would make loading and saving tape images a lot faster, as well as disk images if we get to that point sometime. Okay. Whew, boy, I'm going to read the manual before diving into this anymore. I don't want to start doing stuff to it until I understand the things. Oh, I wanted to mention. So it can do RS-232 level stuff, but you see there's only one regulator on here. There's a 5-volt regulator, but no, the line level conversion, the RS-232 level conversion that it does is really, it's really something. Look at this. Hopefully there's nothing weird up here in my tabs now. Instead of using 1488s and 1489s, I guess those weren't around yet at the time that this board was made. It uses optocouplers and transistors to quote unquote manually switch the unregulated positive and negative 18-volt power supply rails onto the RS-232 port, which I think is amazing in a amazingly Baroque way, right? So that's pretty cool. And yeah, let me switch you back here. Bench cam. Where's the bench cam? Here's the bench cam. So my guess is that these are the optocouplers right here. So yeah, I guess that's it for now. I'm going to read the book. I'm going to go to bed and pet the cat and read the book and figure out how it works. And then maybe tomorrow we can do exciting things, assuming there isn't any calving fuck-uppery that requires my attention too much of the day. All right. Thank you for joining me, gentlemen. I will see you next time.